Welcome. I would like to welcome you all to this session. As you probably know from the title, this will be about blockchain, more specifically the fundamentals of blockchain. I will try to make you guys have a better grasp of the technology. Again, welcome. Before I share the presentation and we can actually begin with the slides, I will want to go through some housekeeping rules. So first off, this won't contain any information regarding prices, price movements, stocks, tickers, anything like that. This will just be about the technology and the possibility offered by this technology. Since we are on Zoom, we have a Q&A section, which you'll be able to ask questions there whenever you have them. I have multiple slots during the presentations where I will take questions, but they are regarding the previous content. So you can ask questions anytime. If they're related to what has been talked about, I will answer them. If not, I will try to leave them for the end of the presentation. Also, my colleagues will share a cheat sheet I prepared for the session. It contains some basic information I think you should have. They're not necessarily easy concepts because, some of them are complex. However, it would help with understanding some of the concepts before you ask them in the chat, like what is this, where is that? Obviously, the question you can still be asked in order to ask for further information, but nonetheless, you can have the information a bit more available like that. If there's any feedback during the presentation regarding my presentation style, the speed at which I talk or anything like that, just let me know. Sometimes, I tend to go a bit faster when I'm enjoying certain stuff. So do let me know. And I think with that, we can start. Yes, okay. So can you guys see my screen? Great. So I'll just get into it because, well, there's a bit of content, so I would like to go through the content quite well. Who am I? Well, I'm currently working for Pentalog. I'm a full-stack developer. However, my formal education has been marketing. I studied marketing at Coventry University. I finished that. After finishing, I decided I didn't want to do marketing, so I shifted towards programming. However, it's not necessarily an easy transition, so I decided to do a bit of mixture of both of the fields. So I started being a business analyst. In the past 5 years, I transitioned to a full-stack developer. I managed to get together some money, and then I decided to become an investor. And for the past 2.5 years, I've been a blockchain enthusiast. What does that mean? Well, obviously, I started by investing a bit, losing a bit of money because it was the top of the cycle, as it happens. And but then I was like, okay, I lost some money, but this is really, really interesting technology. And for the first time in my life, let's say, I found something that was super interesting. It was technology related. I was always passionate about technology, but I was like, wait a minute, I am a developer. I learned how to do this developing, programming stuff. Maybe I can learn how blockchain actually works more than just reading a hypothesis in an article. And that's what I did for the past 2 years. I started learning about the process, how it works, what you can do with it. And here am I some years after, and I am very fascinated by it. I'm still fascinated by what it currently is. And actually, I'm even more fascinated regarding what it could be and what it could mean for the world. And I hope I can share some of that passion with you guys today. I also like sports. I've done a lot of them. I still do some of them. And and this is a fun picture of me because I don't want to come off as somebody who just does programming, because I sometimes have fun, not all the times, but sometimes. So in terms of contents today, we will talk about what blockchain is. I will go through some of the basic aspects. Then I will present a bit of Bitcoin and Ethereum. I will compare the two most famous consensus mechanisms. We'll go through what they are a bit later, which is proof of work and proof of stake. Then we will see why would we use, I'm not gonna mention NFTs at all in this presentation because this is much more related to the groundwork of the technology, not that much actual implementations. That will be done in the second session, but we'll talk more about it later. So yeah, I will talk about why we should use blockchain. Well, not why we should, why we should use it, because it is an interesting technology. And lastly, I will mention some of its technical characteristics and its relationship to privacy, because that's all. I think this is a very cloudy concept. Some people think it's super private and nobody knows what's happening anywhere. And well, actually, it's quite the opposite, but we will go through that a bit later. Yeah, so let's start. Like I mentioned, the cheat sheet, it's also in the chat, at the top of the chat. You can go and access it. You should be able to access it. Again, if you have any questions about any of the concepts, put them in the chat. Good. So the first section is, what is the blockchain? Well, in a nutshell, the blockchain is, well, it's a chain of blocks. And yeah, we could stop here, but I think you might want to know more. It's basically a chain of blocks, and those blocks contain transactions. Okay, why? Well, it's basically an interconnected network of computers. This is just for the groundwork, right? Which have decided to work together in order to keep a network going. That network, we will look at the example of Bitcoin for proof of work. That network is just a balance keeping mechanism. It's like a global bank, which just has accounts and balances of accounts and transactions between accounts. Obviously, some of them have more functionality than this, but for the groundwork, this is it. So since this is what the network is, you have transactions that want to be propagated through the network. Those are grouped into blocks. These blocks are being processed by some entities. And at the end, when they are finished processing, they are put in this ledger, which is immutable. Now, how is this immutability obtained, you ask? Well, it's actually by sheer processing power, in the sense that, again, we'll go deeper as the presentation moves forward, but the idea is that it's immutable because the processing power that is required to change something in the past is actually more processing power than it is required right now to keep the chain going. So basically, there's no such processing power available, because if there was, it would be used to keep the chain going. Yeah. Also, what's super interesting here is that the way these blocks are verified and are certified by the network to be valid is a hash. As you probably have in the cheat sheet, a hash is just a transformation of some information into a very, very specific information that a computer can verify its origin and the result. Yeah. So yeah, like it's mentioned here. So in a hash, you have the plain text, you have a value, you have a text, whatever it is, you put it into a hash function, and at the end, you have a result that can be fit in certain parameters. However, it is not deterministic, meaning that you will never be able to know what the information on the left will output. However, there are certain ways for certain hash functions in which you can verify that what has come out is actually from this source. So this is a hash. And in this particular example, this hash is an intense programmatic race, because it's a mathematical equation that gets computed by tens of thousands of computers at the same time with very, very high hashing capabilities, in order for those computers to be the ones who win the race and, well, get the money. Sometimes what happens is there are certain instances where there are multiple winners in the same time frame. This is called forking. So the idea is that as the blockchain continues, at some point, for example, from the block, let's say in the picture, the one that says main chain, there are two blocks which get produced by different computers at approximately the same time. And the question is, how is this solved? How do the other computers in the network know which one is the valid block to continue? And the idea is this hashing is resolved because the mathematical complexity of the operations is so big that there is almost no way for somebody to continuously make in the same time frame the next block. So at some point, one of these chains will be longer than the others, and the whole network will choose that longer chain to continue. Again, we'll go into all of these in detail as we go through. So yeah. I just wanted to give you some ground concepts besides the ones that cheat sheet, and now I'll explain a bit more generally how it works. So, for example, I want to send money to somebody. I have a wallet. My wallet has an address on the blockchain. Let's keep it at that. And I want to send money to somebody else who also has an address on the blockchain. Very good. I have a blockchain client. I say I have this amount in my wallet. I want to send this address this amount of money. Perfectly fine. What happens is my wallet sends the information to a pool of transactions, right? Where all the transactions in a certain area are held. And then they get, one of the miners sees, oh, okay, we have new transactions. So what I'm going to do is I'm going to put, I think for Bitcoin, it's 413 transactions in one block. I'm going to put 413 transactions in this block, and I will try to validate it. Well, I would try to solve this hashing race. So what happens is it takes the transactions, it puts them in a block, it adds some extra stuff in there which are not necessarily relevant for this idea, and it starts doing the intense mathematical things I was talking about, which is this hashing. Okay, at some point in this network of this network of computers, some of them will find the correct result for this computational operation, and they will say, okay, I found a candidate. Well, I had a candidate, and now I found the result. I'm going to post it, right? Just like posting a post on Facebook, let's say. And then the other computers in the network, what they do is they validate the information themselves. So all the validation that was done by the miner before executing the computational race, checking that I have the balance, checking that the address exists and all of that, the other miners who haven't solved the computational race before me will still validate the information I propagate. So they can say, okay, this is not a valid block. And since this mesh of interconnected computers works in such a way, if I try to fake this, right? Let's just say I go into the source code of Bitcoin, I try to hack it, and I will just propagate a block of transactions, which is invalid. And I'm sending myself 10,000 Bitcoins. Since this is a peer-to-peer interconnected mesh of computers, the moment that transaction leads to any of the blocks connected to mine, they can just validate it and be like, yeah, this is invalid, dude. I cannot do anything with this. I'm not going to send this further because this is how information gets propagated. It goes through the entire network. It's just like with MLM campaigns that they tell you recruit 5 people. Yeah, and if you do this 15 times, you recruited the whole globe, but whatever. It's basically that, but with computers. So yeah, the idea is that after you have the block, you solve the race, all the other nodes verify the block, and if it's valid, and if every node in the block says, okay, it's good, then basically as they start adopting it, it will become permanent in the blockchain. Now, this is something I want to touch upon, which is immutability. The idea of immutability is that I created the block. I ran some computations upon it. I used some processing power. In blockchain, the processing power required to mine each node gets increasingly difficult based on how fast previous nodes have been solved. Meaning that if it's too easy, it gets hard really fast. And if it's too hard, in time, it will get easier. The idea is that as we go through time, trying to create blocks that make sense and respect the rules of having the correct hash in the past and being connected to one another becomes increasingly hard. So if we are here and I require, let's just say 1 terahash. Terahash means a trillion transactions per, a trillion hash per second, right? If I require 1 terahash here, this probably requires 1 terahash minus 5%, let's say, right? The idea is that it gets slightly easier at times if you go back in the past, but you still need the current hashing power to start building them from the past. The idea is that around 6 confirmations, meaning 6 blocks built upon your block, the transaction is immutable. Like the odds of somebody having the processing power and the capability to rewrite history 6 blocks ago is mathematically impossible. Okay, and now I'm gonna talk a bit about Bitcoin more in particular. So Bitcoin was released in 2009. The first block that was mined had the message, it was a headline from the Times, which said 3rd of January 2009, Chancellor on brink of second bailout for banks. This has 2 reasons and utilities. The first one is the fact that it sets a timestamp. The blocks have timestamps themselves, but it wanted to set inside the Bitcoin network what was the current feeling of the world. And it's not accidental that they mean second bailout for banks, because Bitcoin, one of the hypotheses is that it has been constructed as an alternative to the current financial system, right? So yeah, like I mentioned before, miners will attempt to verify transactions and construct a block. Now, the idea is I won't go into super complex mathematics here because, yeah, there's not really no purpose, because you can find this information. It's actually quite easy available, but you need some ground concepts in mathematics and computing that probably either some of you have them, some of you probably don't. But the idea is it doesn't matter, because there are other people who are super smart who have tried coming up with edge cases, and so far the network having been hacked, it's pretty much, you can pretty much be assured that it's super safe from the mathematical and technical aspect. Okay, so like I mentioned before, Bitcoin uses proof of work. Proof of work is a consensus mechanism. What people mean by consensus mechanism is, what is the way in which we agree that something is correct? That is the consensus mechanism. In the case of proof of work is exactly what I told you before. The idea that you use work, and in this particular instance, work means processing power, implicitly energy and technology, to solve complex mathematical computations in order for you to prove your worthiness to the network and for you to have a stake. Well, stake is probably not a good word here, and you'll see why later, but for you to be part of the network. Because the idea is, if you have complex hardware which run complex operations, they use a lot of energy. If you're not sure or you're not willing to actually do stuff for the network, you won't use those resources, because you will just lose them if the network invalidates your transactions or your blocks, let's say, right? Okay, regarding this hash, this hash is not deterministic. So the idea is, this is mathematics, but there's no way to do it smarter. So for example, you have certain mathematics that you have shortcuts, right? In the way you solve a mathematical problem. Yeah, you cannot solve this mathematical problem with shortcuts. You just have to, what in technology we call brute force. You just have to run the same thing over and over and over again. In this particular case, in the case of Bitcoin, they use, so summing stuff up, you have the header of the previous block, and the current block you are mining is trying to hash that header once and then hash it again, and then have a result under a certain value range. The idea is that it's not deterministic. You cannot spoof it. You cannot fool it. There's no way to go around it. You have to put in the work. Okay. Like I mentioned, proof of work requires firstly computing work, but that's not it. It requires energy. And as you've seen, energy right now is super expensive. And it's not only expensive, it's also not very available. For example, China has had problems at the beginning of the year or the end of the last year regarding coal, because they have a lot of their energy based on coal production. They don't have that much coal. They were actually importing them from Australia, which is quite interesting. But the idea is they were shutting down production plants for certain goods because they did not have energy. So energy is not something you have readily available anywhere we go. We might have it for like our sockets, but for these computers which run on super strong hardware, which have very big energy uses, they're not so readily available. So then if we assume for the sake of the discussion that the technology is safe, the mathematics is safe, and the network is okay, but there are some bad actors, what are the attack vectors, let's say, right? Well, the first barrier is resources in general, energy, and computational availability. The way I would like you to think about things is, let's say, let's use the terahash example. If we think that the current network now has 1 terahash, whatever 1 terahash would be, right? If you need to have a majority of that mining power in order to corrupt it, that means you would need to come up with those computational resources. The idea is it's not easy. First off, you need the know-how. It's not easy to build super specific high-tech hardware specialized just for this, right? This is not something you just start building. There are companies who have done it for years and they have improved on the design. Secondly, like I mentioned, electricity, it's not readily available everywhere. You need to be in the correct space, in the correct place, with the correct connections and everything, and have access to these types of resources. And lastly, the computation availability themselves, in the sense that you have to have this capacity online, or you have to bring it from somewhere. Now, the idea is that, yes, it's potentially possible, but the way the technology has evolved is that we currently use ASICs, right? So the idea is that these are specialized computing devices which only do this. So if you can imagine that your phone has 10 functions, yeah, that's perfectly fine. It's designed to have multiple functions. That's not the case with an ASIC. With an ASIC, the core reason that device exists is to compute transactions and blocks for the blockchain network, which means that, again, the know-how here is absolutely incredible. So yeah, the idea is that it's almost impossible to actually happen. It is possible in theory. Furthermore, what's interesting here is that, for example, let's say I'm a malicious miner, right? On the blockchain itself, when you do transactions, if I want to do transaction from my wallet to somebody else's wallet, I need to sign my transaction with only a key that I own. So the idea is, even if the miner is a malicious actor, it cannot actually use any of the currency in my wallet because it cannot have my signature. It won't be able to validly sign my transaction in my place. So it will be an invalid transaction as it is for the blockchain. The technology itself won't allow it. So yeah, this is, I just brought this graphic so that we can have a clear vision of how this cycle continues. And just to sum it up a little, you have the transaction here. I want to send money from A to B. We have the miners, which we assume they're decent people, right? The miners put transactions into the block. They solve the block puzzle. They attach the proof of work, which is the newly computed hash, to the block. They broadcast it to the network. The other miners verify it, and then the process starts over and we can look at new transactions. So yeah, I will look a bit on the Q&A right now. And if there are questions regarding this first, and then If there are other questions more general, I will answer them either now or later. Okay. I will take Edward's question. What about launching thousands of fake miners? The idea is, what would you do with fake miners? You could potentially, for example, spam the network like a DDoS attack, where you just try to make a lot of miners, connect them to near nodes, and you would try to spam transactions. The idea is that in the end, the miner itself, the blockchain client implementation itself, is a software. Like the way you solve direct denial of service attacks on a regular software is, if somebody is spamming you with bad stuff, you just basically block them. So the idea is, yes, you could potentially launch a DDoS attack on the whole network, but at some point, participants will just block your access. They will just be like, yeah, this guy is sending me rubbish every time. I'm just going to put it on an ignore list. And if you do this long enough, you won't be connected to any nodes, right? And I'm not sure, but I wouldn't be surprised for there to exist like a blacklist of nodes which do this, well, or basically a blacklist of IPs. I will talk about privacy at the end. Okay. I'm going to try to answer Liliana's questions. The idea is, all nodes, if any node, or if one of the nodes are off, the idea is the nodes which are off, they don't do anything. So this whole thing revolves around the idea that you have nodes that are active. You're actively taking part in safeguarding the network. If you're not there to do your job, well, first off, as the networks are intertwined and connected, if you're offline, it will just ignore you and connect to a different node. I'm not sure if that was the question. No, so this is Aman's question. The question is whether mining difficulty increases due to more miners joining the network, and not necessarily that the next block is simply harder. So no, I hope I understood this correctly, but the idea is that the mining difficulty increases based on how fast the previous, I think, 20,000 blocks were created, how fast they were created. I think it's like a number of weeks or months. So they look in the past, and if the average is under 10 minutes, they will increase the difficulty to keep it at 10 minutes, because this is the idea. The ideal target for the blockchain, for the Bitcoin blockchain to have a response is 10 minutes. So if it's less than 10 minutes, it's going to be harder. If it's more than 10 minutes, it's going to be easier. But it's a function that happens all the time. And at each block created, they will try to recompute this. Yeah, so the other question regarding a block can contain, yes, you can basically validate a block with a single transaction. There's nothing wrong with that. I mean, it will always have 413, but it needs to fill the space, but it will fill the space with empty transactions. It doesn't matter why that is, but the idea is it will fill the space with empty transactions, and it doesn't matter. It will just propagate the actual one transaction that is relevant there. Okay, I'm answering the question regarding the taxes on your wallet. And well, the idea, Edward, is actually, I think I'll leave this discussion for the end, because it's actually connected to some other aspects. And no, regarding is the network energy efficient, the answer is no, it's not energy efficient. I have read reports that say that it's using basically 60% of its energy from renewable sources. Obviously, there's no way for anybody to actually verify this. You have to go by probably the big companies who have networks and what they say. But the idea is that it could potentially be 100% renewable energy, and it would be one of the best systems we would have in our collective history, right? Because it would be something that is bulletproof in terms of security. It's untamperable by anybody. There's no central authority, and it would be basically free because, yeah, we would use renewable energy. How many consensus mechanisms there are available? A lot of them. Like there's a lot of them. Off the top of my head, I know proof of history and proof of space. There's one called, I think, proof of space-time. Yeah, these are just variations, which it's just the way they come together to decide what is the truth, and then basically what they agree upon, and how the miners or validators prove that they're willing to actually help the network. Okay, let's go on. And Edward, please remind me at the end to answer your question regarding the taxation. Okay, cool. Now we go to Ethereum and proof of stake. Yeah, the idea with Ethereum is that it started with a guy called Vitalik Buterin. He is actually one of the co-founders. He is a guy from, I think he's originally from Ukraine or Russia, and he moved to Canada, and he was a student there. When Bitcoin came out, he was working for Bitcoin Weekly, which is like a magazine, and then it shut down, and he became a co-founder for Bitcoin Magazine. And as he was doing these technical articles, he started actually looking at the code. And at some point, well, obviously this is oversimplification, he was like, this is not enough. This is just basically like a global bank, right? Why couldn't we do something more complex? So he got together, I think, with 6 other guys, and he created something which he thought it was better. I tend to agree that it's something different. And that something is called it's called Ethereum, and it currently uses proof of work. However, it is transitioning to proof of stake. I could have compared the proof of work of Ethereum with Bitcoin because it is different, but I thought that would be not that interesting, and going into proof of stake is much more interesting, and Ethereum as a chain does much more than Bitcoin. Okay, so the idea is that, like I mentioned, Bitcoin is a global bank, super cool. It does everything what it needs to do. It does it well, very reliable, awesome. That's kind of boring, like in the sense that it only does that. We could use it for that. However, it's really, really hard to do anything on top of it. This guy, Vitalik, he was like, what if we created like a global network of peer-to-peer entities that can actually do some computation on? Okay, that's a good idea, right? So he created this peer-to-peer computational network called Ethereum. They added support for something called smart contracts, right? We'll get into smart contracts, well, more deeper in the second presentation, but a bit later here about them as well. This is the same idea as Bitcoin. However, instead of having these miners, because they're still miners now, they will be validators in the future, instead of having these miners just confirm transactions, they also do some operations, which are executing these smart contracts. In a nutshell, smart contracts are pieces of code, right, which are self-contained in a container, let's say, which you deploy on the network. You can never change, and you can only call them. In programming, we have a concept called, maybe some of you have heard about it, serverless functions, which basically mean you create a piece of code, you don't need any type of computational architecture for it, right? And you just tell this, let's say, website, Amazon, yo, run this computational operation for me. Amazon says, okay, it gives you the result. This is called serverless, right? In a nutshell. Ethereum basically does the same thing. So it has this smart contract language in which it allows you to do programmatic syntax to create logical structures which have functions that can do functionalities. For example, in the second presentation, I actually have a demo with this. I created a bank. It's a bank. Well, it's a simple bank, but it's a bank. The idea is that you have this smart contract on the Ethereum network. You have three operations. First one is deposit. The second one is withdraw. And the third one, I think it's called deposit too. Not the most creative name, but whatever. The first one allows you to deposit money into the bank's balance. The second one to withdraw money from the bank's balance. And the third one to deposit money into the bank's balance for somebody else. And it just keeps internally a record of how much everybody has. This is basically exactly what Bitcoin does. However, it's customizable, which is awesome, right? Because I created my own logic. You can basically create a sports betting company with a smart contract. You can create an acquisition contract with a smart contract, for example, buying a house, right? You can tell somebody, I have this smart contract. If you prove me, you can sell me the house, I will send you the money. It's super interesting, but again, we'll go into it a bit further. Now, Ethereum is also permissionless. And it's not necessarily permissionless the same way that Bitcoin is, that anybody can use it from anywhere. It's more than that. When you have the smart contracts actually deployed on the network, basically anybody can call them. So if I have a smart contract that does something really, really nice and interesting, anybody can say, use Adi's function to do X. And what's even cooler here is what I like to call Lego smart contracts. The idea that you can use somebody else's smart contracts to build, well, a business case, a proof of concept, anything, which I think is really cool. Okay, now I'm going to talk about proof of stake, because like I mentioned, Ethereum right now is proof of work, but it will be proof of stake. So I'm going to talk about proof of stake. Proof of stake, instead of miners, they have validators. Regarding the question that was asked in the chat, network energy efficiency. Yeah, validators use 99.95% less energy than miners. Why? Because they don't run any mathematical operations. Their proof is not of computational work they have done, but is rather of the network having considered them to be trustworthy enough to get a stake of the network given to them. The idea is that these validators have a minimum staking amount themselves. Like when you start this validator, with a miner, you can just turn on your computer and you start mining Bitcoin. You'll never, ever, well, probably never, ever earn a Bitcoin, because whatever device you have at home is not even comparable to anything running the network at the high-end level. So it will never be, you'll never win anything. You'll never win a block, right? But with validators, the idea is that I can start my own validator. If I have the minimum amount of Ethereum in this case, and I put it there, I will tell the network, yo guys, I want to be part of the network. I deposited some money here. Maybe give me some transactions to validate. And the network will be like, yeah, okay, you deposit the minimum staking amount. Staking is like depositing money in a bank account, which you don't control. I'll get to it a bit later. Okay, so you deposited the minimum amount in this bank account, and yeah, you can validate some transactions. The idea is that instead of miners, where this is a direct computational race, for validators, it's a pseudo-random way of giving validators transactions to validate based on multiple aspects. One of them is how much they have staked in the network, not by themselves, but by everybody who has staked with them. The idea with proof of stake is that, let's say there are 100,000 Ethereum in circulation. Out of those 100,000 Ethereum, if you can convince people to give you 20,000 Ethereum, you will have 20% of the Ethereum of the network, which means implicitly you are trustworthy because other people trust you enough to give you their Ethereum to validate transactions. This is what proof of stake is basically. It's a list of entities that try to get people's trust in order to validate transaction. The win-win for the network is the fact that you're not doing intense mathematical computational operations. You're not wasting energy. You're not doing any of that. It's a more trust-based system, right? What happens afterwards? So I will do a direct comparison to proof of work, but just as a thing, what happens afterwards is my node gets chosen to be the validator. I validate the transactions as being correct, fine. The same thing happens like proof of work. I send the block to the network and the network says, okay, this block is valid. We will adopt it. And it propagates the same way, just like in proof of work. Now, what is more interesting here is that there are obviously different proof of work algorithms and different chains who have implemented them in different ways. But in proof of stake, I think the diversity is bigger. For example, there are networks which compare the staked amount you have in your validator node to the transaction value you're trying to validate. Meaning that me, who has staked, let's say, $10,000 worth of Ethereum, yeah, I cannot validate $10 million worth of Ethereum transaction because the node will say, yeah, Adi, you have some of the network stake in you, but you just don't have enough, right? I don't think you're trustworthy enough for you to stake this amount of money where you have so much less in your balance. Other networks actually have what is called the diminishing returns mechanic, in the sense that if you go over 10% of the whole network value being staked to your node, you're going to get less chances to validate. Why? Because they're trying to encourage the people to be more decentralized. And you will hear this word a lot in the blockchain community, decentralized. The idea is to lack a central entity so that it's uncontrollable. Yeah. Because Ethereum supports smart contracts, they have layer 2 blockchains built on top of it, which helps with efficiency. But yeah, we'll talk about that a bit more later. Okay, so the same thing, just like with proof of stake. How does it work? Well, the idea is, yeah, like I mentioned, the owners stake their tokens into the staking pool or validator nodes. Then the algorithm pseudo-randomly selects a validator. The selected validator groups transactions into blocks, validates them, sends them to the network. The network validates that its validation is correct. The block is added to the existing blockchain, and the validator earns a fee, just like with proof of work. So another section of the Q&A. Does anybody have questions regarding proof of stake? Let me see if there are any questions. I'm sorry, somebody asked, are there many blockchains in a system? Example, Bitcoin. I'm not sure what you mean by that. The Bitcoin itself is a blockchain. The whole thing is called a blockchain. I don't know what you mean by blind signature mechanism. If it's a specific concept, I haven't heard of it. I'm not sure what it is. Yeah, it's very interesting what will happen with Bitcoin and with proof of work if the value doesn't go up, because like you say, I think right now the break-even point to mine Bitcoin is something like $11,000 per Bitcoin. That's how much it costs. Obviously, again, renewables, all that processing power, it's hard to gouge, but the idea is that around 11,000, it's not profitable to mine it anymore, which is interesting. What will happen then? Yeah, I don't think there's any legal representation regarding smart contracts. There's no link to the legal authorities in Europe or anywhere else. No, the idea is that the processing required to validate transaction is so small that you don't need super performant hardware. So you can do it on a laptop actually. But yeah, there are also mechanisms to prevent nodes who do not update or propagate transactions long enough. So there are safeguards inside the protocol for that. Okay, let's move on. So yeah, like I said, these two consensus mechanisms, proof of work and proof of stake. The idea is, I made this analogy before, proof of work is like having money in a global bank account, where proof of stake, it's basically like having shares in a global set of companies, right? Because you can choose whatever validators you want, whichever validators you trust. You can go and you'll be like, okay, I like these guys. Pentalog Cluj has a validator node. I trust them. I'm going to validate with them. Awesome. It's like buying company shares, right? Like I mentioned before, well, actually, I'll make this, example now. Bitcoin can be attacked with computing power. Ethereum, however, when it moves to proof of stake, it won't be able to be attacked with computing power because there's no computing involved. However, it will be attackable with financial power. The idea is that you would need to own 51% plus of the value of the network in order to do the same damage you could with Bitcoin, which it gets more interesting because with Bitcoin, you would just need to buy computers and then, yeah, try to use them to attack the network. But with proof of stake, you need to buy those tokens, and actually staking and the whole process behind it, you're not allowed to withdraw it instantly. There's like a withdrawing time. I think it's like 21 days or 7 days, depending on the blockchain. So if I put the money in a validator, we get a majority stake of the network, we do some bad stuff, the network price starts going down because people notice the network is not performing. By the time those 7 days finish, basically what happens, its value will go to zero. And remember the bank balance I told you regarding the minimum deposit? The idea is that if you don't follow the rules of the network and the network decides you are malicious, it will slash. It will literally take that money from you, take those tokens from you, right? So you're incentivized, you're financially incentivized to do a good job. I wanted to also touch upon the blockchain trilemma here, which is the idea that blockchain networks need to have three main characteristics. They need to be secure, and we spoke about security a lot about security, right? It needs to be untamperable, it needs to be safe, it needs to have defensive mechanisms, right? And it does, like proof of work and proof of stake have defensive mechanisms built in the tech to see when certain malicious actions have been taken and alert the network. And then the node operators or the miners can take actions themselves. So it does this, right? And obviously, there needs to be a barrier of resources in order for the network to not be attackable. It needs to be scalable. And yeah, like the questions were asked regarding scalability and speed and all that, it's true. It needs to be scalable. Bitcoin isn't scalable. Ethereum isn't scalable. There are certain solutions proposed to this. Some of them are good, but it will need more time to mature just in terms of this scalability, right? And lastly, it needs to be decentralized. There doesn't need to be a central entity that controls everything. And like we talked with the miners, they're all over the world. They have to obey the laws of the network, but they cannot do whatever they want. Same thing with the validators, right? All over the world, they have their strict law, and they just follow it. Yeah, this is a small comparison between proof of work and proof of stake, right? Like we mentioned, computational power versus stake of the network, cryptographic puzzles to solve in order to earn rewards. They don't need to solve anything. They just collect transaction fees when the solution is correct. In order to attack a proof of work, you would need 51% of the network to attack in terms of computation. With proof of stake, you would need 51% of the network value to attack, which is, again, it's interesting, right? Now, we're almost done. The idea is, why would you choose blockchain over anything? Why would we use it? Like I mentioned, Bitcoin came really close to the financial crisis. I don't think that's a coincidence. I think whoever built it or whoever has been building it, they knew exactly what they were doing. The blockchains as a technology, they're not new. So for example, Bitcoin, the way it is right now is the result of approximately 20 to 25 years of technological development, in the sense that the concepts it used were, in the past 25 years, they were formulated. So it was really, really longly thought out. It wasn't instant. Somebody didn't have an idea and then the second day they had the blockchain. It wasn't like that. They used super, super complex technology that was currently being created. So yeah, it tries to fight centralized control. If you trust your government, and I'm not saying you shouldn't, the idea is, in a best case scenario, your government is good, your institutional partners are good, everybody is a good actor. In that case, maybe we wouldn't need blockchain. But the truth is, not everybody is a good actor. And it's not about being necessarily evil. Even financial decisions, like even the people who take decisions in a company or in a government or in whatever entity that has control and power, they can make mistakes. The idea is that if we have a logically fail-proof system, these mistakes cannot happen, right? So the idea is removing somebody's ability to control the network. Another thing is third parties. Third parties make our lives easier. For example, you want to buy a property, you go to a lawyer, you go to a notary, and you tell them this and that, and you do the contract, and everything is fine. You get your property. The idea is they have certain fees you have to pay them. And I'm not saying they're not doing a good job. Probably most of them are doing a good job. They're following the laws. Some of them don't. They go to jail, whatever. But the idea is, why are they needed there? Because you could potentially program certain aspects of the law, which with logic, into a smart contract and then remove the need for these third party, which, yeah, basically certain institutional clerks, they just follow the law. They don't provide any personal value, right? So then it might be easier if we find a way to automatically solve some problems in society. Like I mentioned, decentralized, the idea is there's nobody stopping you from participating in the system. The only way you can stop these networks is by shutting down the internet worldwide and killing all the miners. Well, shutting down all the miners. That's the only way you can stop the network, which means it gives freedom, it gives people a certain degree of freedom of money and their resources to be movable. One super interesting aspect here is it discourages the gaining of the control of the financial system or any system for that matter, because think about authoritative leaders or people who, for example, like Hitler, let's use Hitler, right? He wanted to become the Chancellor of Germany in order to have power, right? Power to do whatever he wanted. The idea is that with blockchain, the way I see it, you are discouraged to obtain control of the network, because if you obtain control of the network, all the value you have tried to create by controlling the network will go to zero, because the network itself won't trust itself and the people won't trust itself and it will die. So it basically disincentivizes anybody to try to take control, right? Because why would you try to take control, put all this effort in something that it will just basically stop itself if you control it? I think this is an ungovernable aspect of blockchain, which I like. Lastly, like with the freedom of money, this is unrestricted access to technology and computational. For example, in the terms of Ethereum, if I want to create a smart contract that anybody can use to do X, Y, or Z, I can do that. And there's nobody around the world who will tell you, you cannot use this function, you cannot use this computational network. Not Amazon, not nobody, right? And yes, arguably certain entities should be banned for using certain computational networks, but the idea is that maybe we can find ways to do that in the certain landscape that we have, not computationally, because again, it's the same thing with the third party. Amazon has had instances where it unilaterally decided, I don't want to let this company operate on my network. And yeah, it's fine, it's a company, right? But it's maybe not fair, because maybe it's not their decisions, especially if there are customers for that product. Some further information here is regarding the current global monetary system that we have. Some of you probably heard about the gold standard. Some of you heard about the petrodollar, reserve currency. The idea is that the world has seen an evolution of finance, but objectively, we are not in the best place of global finance right now. What is called today modern monetary policy is just basically a wild inflation ride. There's no basis for it. So like, for example, you probably heard people that there's no value behind Bitcoin, right? Well, there's no value behind the money you're using right now, like literally no value. We have something that is called fractional reserve banking, which basically creates money out of thin air. Governments, they print money out of thin air. So what I like about blockchain, because we are talking specifically about blockchain here, is the idea that with these systems, you can choose whichever monetary policy you like. For example, Bitcoin is fixed supply. If you like the concept of fixed supply, you can use Bitcoin. For example, Ethereum is inflationary. However, there have been certain proposals that were accepted, and there have been months where the traffic on the Ethereum network made it deflationary, meaning that your money, instead of like with inflation losing value every month, it gains value every month. I think that's kind of cool, right? The idea is that with these blockchains, you can choose which one you think is the best one for you, right? Yeah, this is an interesting graph I've seen before, and this is adapted, and it shows the devalue of the dollar. Usually this is something like, you see that the dollar had $1 value here, it's 100%, and now it's, I think the devaluation of the dollar for the past 100 years has been 96%. So it has 96% value that it did then. And as an example here in, I think this is, 1910, I think, or 1900s, you could buy the equivalent of $26 worth of Hershey's chocolate with $1. Well, the prices of today, right? Whereas right now you can get a coffee from McDonald's. So I think that's an interesting comparison. Also, you can see the events that have happened to lead here. And the latest one has been the response of the US government to the coronavirus situation, where, yeah, at that point, when this graph was made, it was 20%. I think I've seen numbers up to 40 or 50%. And that's quite insane. Okay. Just to summarize a bit, these are the technical characteristics of the blockchain technology. It's decentralized, it's open source, it's perfectly transparent, anybody can look at it, it's immutable, they have super high-tech compression, hashing, proving mechanisms, consensus mechanisms, and it's available 24/7. As long as there are validators and miners, it's online. Lastly, like genuinely the last topic, is privacy and security characteristics. Most of us know about GDPR. I was asked to cover GDPR in this presentation, and unfortunately, the really quick answer is, yeah, it's not GDPR compliant. None of it is GDPR compliant. There are multiple rules GDPR compliance needs to follow. One of them is allowing users to remove their own data. That doesn't exist. So somebody asked about the transparency of it. Yeah, the idea is that on the blockchain, absolutely everything is visible. All the transactions that have ever happened are 100% traceable to what is called the Genesis block, which is the first block that was ever released, which is the one that had the message I told you about. So from that perspective, there's no way to remove information about transactions. There's nothing you can do to be GDPR compliant, right? What you can do, especially in proof of stake and smart contract networks, is you can use oracles or you can use privacy preserving blockchains. We'll go about what these are in the second presentation. But the idea is that there are very advanced networks, which oracles are real life companies which you can use inside the implementation of your smart contract on the blockchain, which you can agree to get reliable information from. And privacy preserving blockchains are blockchains that basically, like the thing I told you before with a hash, it allows you to encrypt the information you store on the blockchain so that it's not human readable. The algorithm, using your key from your wallet, can decrypt messages. So that's kind of privacy preserving. The idea is, yeah, it's still permanent. However, if nobody has the key to see it, it's kind of privacy preserving. Yeah, like I mentioned, the traceability is almost perfect. When you include centralized exchanges in this equation, absolutely all transactions are traceable, and you can pretty much trace it to a human being if they have ever deposited or withdrew money from the blockchain network. So the idea is, if I'm involved in a hack, I steal some Bitcoins. If I have deposited money to that address or withdrew from it, or sent money from that address to 100 other addresses, but removed money from any of them, a centralized exchange can call the government and say, this guy, which was connected to this address, has withdrew money and his name is Adrian. Go get him. And I'll have the FBI at my door. And lastly, what's something concerned about security is smart contract risks. Smart contract risks is a really, really relevant and important topic. They're super complex, but they will be presented in the second presentation when I actually go into the details of smart contracts. Yeah, this is a summary of what I spoke about today. I will get to the Q&A and I'll answer some more questions, but just so that you can have an idea about what we spoke today as like a leaving thought. We spoke about what blockchain is. I told you how the data structure looks, what it can do, you know. I told you what Bitcoin and Ethereum are, how the networks are similar, how they're different regarding, for example, Ethereum has computational power and all that. Told you the differences between proof of work and proof of stake. One of them uses intense mathematical computation. The other one uses a consensus based on trust, right? I told you why we could potentially need blockchain in our lives, because it has some advantages over the traditional monetary and financial systems. I told you why we would use it as a societal requirement, because it is more free and easier to use. What its technical advantages are, all the things regarding the consensus, the hashing, distributed aspect of it and all that. I told you about privacy, GDPR. And lastly, when I did the presentation, the teaser video for this session, I thought saying that I will tell you what blockchain is and blockchain isn't would sound really cool. But then I realized it doesn't make sense. And I decided to come up with a joke. So the idea is, after all the things I've just told you, I can definitely say that, and hopefully you can say that what blockchain isn't is magical. It looks magical. Some of the things it does is really, really impressive, but it's not magical. All of it is deterministic. All of it is code. All of it is out there in the open. There are no secrets, but also it's kind of awesome. And I think it has the basis to form the foundation for a really, really strong economic future where we all can have the same rights and the same say in what it does and how it operates. And we get to the final Q&A. I think I'm going to drink some water because I will go to the questions again and again. If you have other questions, drop them in the chat. Yeah, this has been an hour. It was kind of long. If anybody would like to stay more, if I have questions to answer, I will continuously answer them. So regarding, I'll actually go back to Edward's question regarding why would the government stop? Why wouldn't the government be able to tax us? So the answer is, if they don't know who the wallet belongs to, just so that it's clear, I'm talking about, I'll put the question in the chat. So the question why the government wouldn't tax us, the government could tax us, but it doesn't know who the wallet belongs to. So as long as you remain 100% inside the blockchain ecosystem, and for example, inside the Bitcoin ecosystem, the government wouldn't know who to tax. Yeah, the moment you actually engage with fiat infrastructure and basically with banks and all that, the governments would know who to tax. But the idea is taxes, if they're not overdone, is not necessarily a bad thing. For example, like road taxes. I don't mind paying a road tax if you have good roads. So for example, if the Romanian government in this instance would be like, we would like to tax Bitcoin. However, we will create a Romanian government mining node. I'd be like, okay, cool. If you want to tax Bitcoin, we will create a Romanian government mining node. But if you want to tax Bitcoin, we will create a Romanian government mining node. I'd be like, okay, cool. If you want to tax Bitcoin, we will create a Romanian government mining node. yeah, okay, that seems fine. I guess that seems fine. And like, if you're going to adopt this technology, you trust in it, you think it's going to be the future, and you show that you're willing to contribute to it, I will pay you taxes for it. No problem. Absolutely no problem. Right? Also, for example, like I mentioned earlier with oracles, if the Romanian government says, in order for, again, oracles are public resources you can call from outside the blockchain ecosystem, from the real world. If the government says every time you call this oracle, you need to pay a fee, that's fine. Super okay. I don't mind. Again, as long as the tax makes sense and they're giving you something from that tax, a tax isn't a bad thing. I don't think so, at least, right? Okay, somebody answered the question regarding Bitcoin is a blockchain. So when I said Bitcoin is a blockchain, I meant to say that Bitcoin is an implementation of the blockchain technology. So, and I mentioned there are, if you think there are 20,000 crypto tokens or coins available, and the question is, are there 20,000 blockchains? The answer is no. So for example, on the Ethereum network, you can have tokens. I actually haven't looked exactly how the code works, but I have an educated guess that it's all based on a smart contract. And the idea is that you have a smart contract, and that smart contract emits certain tokens. For example, I think Uniswap token. I think Uniswap token is on the Ethereum network. So no, because there are 20,000 crypto tokens, are there 20,000 blockchain? The question is no. How hard it is to link a trading platform based on a blockchain with real world assets? Well, the question is, the answer is not that hard, in the sense that you would need an oracle, which is the entity from the real world, which would be able, so how oracles work in the concept of smart contracts is like this. I, Adi, want to make a smart contract with you, or whatever, for the world. I say that we should use this oracle, which is the Romanian government, in order to certify that the good I am trying to sell is legally mine in the old legal framework. You, the person who uses my smart contract, will be like, yes, okay, the Romanian government seems trustworthy. I will agree to use that smart contract. So the idea is, once you agree to use my smart contract using this certain oracle, we agree that the basis for our transaction is correct. So then how hard it is to link it with real world assets? If the Romanian government starts an oracle tomorrow claiming that they will tell us who has X property, we could create a smart contract to sell properties on the blockchain the next day and be like, Romanian government, who owns this address, he does, transfer it from him to me, this is the money, everything gets computed inside the blockchain. In 6 seconds, we have our finality, the property is now yours. It's not that complicated, in theory. In practice, the idea is that we don't have this. The Romanian government doesn't do any of this. So yeah, but they will have to do it eventually. Otherwise, probably something in the public sector might take this role. There are some precedents. For example, I think in Germany, there is a company who trades stocks on the blockchain by having the stocks under their own name, and then basically they knowing who the stocks belong to from the blockchain. So for example, this company buys a Tesla share, I buy it on the blockchain. If ever I want to take claim of it in the real life, I'll be like, this is my address, I bought this from you, transfer it to me. And this works. This is an actual real world example. I don't know the company right now, but I read about it. Yeah, so blockchain is global. Right now, we don't have very much taxation overview anywhere in the world. There aren't a lot of taxation guidelines. And yeah, as time passes by, just like with anything, any new technology, anything, it will get taxed to a certain extent, one way or another. My whole idea is, I hope they do it in a decent way, and I hope they provide some value. They might not, because yeah, governments can just tax whatever they want. There are ways to circumvent this, but honestly, I don't want to discredit the technology and paint it with this, I don't know, shadowy atmosphere to be like, oh, you can fool the government. Yeah, you can fool the government. You can fool the government with a lot of technologies, right? But my view of blockchain and my hope for blockchain is that sometime in the future, it will be 100% accepted by the governments, and governments will try to work with it because it makes their job also easier. But they have to have this clarity in order to start doing it, right? Okay, I'm answering the question regarding an evil actor buying the majority stake of a crypto like ETH. Yeah, so like I told you before, if you try, Ethereum is valued at 100 billion or whatever, the prices go up and down, right? If you want to control it, you need to buy 50 billion worth of Ethereum, lock it in a smart contract, right? Basically put it into the validator node, do whatever you can do. And the idea is you cannot do so many operations that actually make you rich. You can do some double spends, but whatever, it doesn't matter. Let's say you can do some harm, and you can do some harm. Once people start noticing that you have done this, you have control of the network, you're doing this, they will sell the governing token, and your value will go to zero or very close to zero, right? So this, like I said, this is the disincentive. If you're trying to control it and you take control of it, your whole investments will be worth zero by the time the market realizes. What solutions are currently proposed to counterbalance the volatility of crypto assets? None. So again, and I'm not trying to be facetious here, this talk is about technology, and let me tell you that besides, well, there are a lot of rich people who are developers or creators of blockchains in the space, no doubt about it. But the ones I've heard talk and discuss this, they don't look at prices. Like, they will sell whatever they have to sell to live and whatever, buy a house or whatever it is. And then they don't look at prices. They don't care about the prices. When Vitalik Buterin wakes up in the morning, he doesn't check the price of Ethereum because he doesn't care. He truly cares about the technology and the potential of the technology, not its value. He is definitely filthy rich, and, well, not filthy rich, but he's definitely rich, and he probably has a house, and he probably has enough fiat money to live his whole life. And he probably has a few 100 million in Ethereum or whatever. I don't know what his Ethereum holdings are anymore, right? But there are no developers that care about the price of their currency. Yes, sometimes the idea is you could, if you're at the beginning and your project is valued at a certain value, and you have, for example, funds for development, if those funds get devalued, you have less money for development. That's true. But that's really the groundwork. But it's no different than a normal company, right? It is different, but it's not different from shares in a normal company. If I start a company right now and I invest some money, I create the product and all that, at some point I will have to, if those shares start to devalue, if I sell them, I make some money. If I don't sell them, by the time they devalue, I won't be able to sell them at the same value, right? So it's just, from this perspective, you should think of it just like shares in a company. Yes, regarding smart contracts being available only on proof of stake, no, you can use them on proof of work. There's some intricacies regarding block size and what the actual computational capacities of the network is. Even Bitcoin has some smart contract capabilities, but they are super rudimentary. Like, you cannot make loops, you cannot do a lot of interesting stuff, let's say. So no, the idea is you can do smart contracts on proof of stake. and proof of work and any other consensus mechanism. Oh, yeah, actually, this is the bibliography. This is by far the most important one. The one on O'Reilly regarding mastering Bitcoin, the book. It's a really good book about Bitcoin and proof of work in general. I'm looking at the question. Isn't having the minimum staking amount of 32 ETH going to slow down the number of validator proof of stake in ETH network, assuming this has an effect on the transaction speed? And how has this limit been established in order to keep the network secure? From what I know, this limit, this 32 ETH is set in stone. It's, you can probably modify it with a proposal, but I don't think it has changed over the years. I might be wrong. And if you're asking this from the perspective that since the value of ETH goes up, doesn't this make it more complicated to be a validator? Well, yes, it does. Is that a good thing? Probably not. However, like I mentioned before, blockchain and smart contracts, for example, are super composable. Like I told you with the smart contract Lego, there's nothing stopping you trying to pull some Ethereum together with some friends to probably provide for this, or just like, again, with any other business trying to get a loan or, you know, a grant of some sorts. And there have been instances where, yeah, people don't have the minimum staking requirement and they go to their social media presence and they ask for their followers. There are, for example, I think on Cardano, one of the top 100 validators or 10 validators is a guy who has a YouTube channel. And he just says in every YouTube channel, please stake with me. So he probably got a loan, bought the minimum staking amount, and then based on how much he validates, he gets more revenue and then he can pay his loan. So yeah, in terms of decentralization and being able to participate in the network, is it good that it's expensive? The answer is no. But yeah, it's for example, even with Tesla in the car market, do you think entering the car manufacturing industry was easy? No, it wasn't. It was probably super hard and it required a lot of capital. And it's kind of the same thing here, right? As the system gets more and more important, it's probably going to be more expensive to be part of that system. Regarding taking a course in blockchain developer, blockchain consultant, if there are any, would guarantee your regular work even as a junior dev. There are certain blockchain courses, development courses, platforms I have enjoyed. There are certain companies who offer courses regarding blockchain development. Some of them are really good. Like I told you, I actually, for the demo I created for the second presentation, I used some of those tutorials and courses. They are good. They explain a lot of stuff. Regarding getting regular work, even as a junior dev, that I don't know. The idea is that, for example, I'm part of some Twitter, well, it's basically a Twitter account you follow, and it posts job openings. Almost everybody is looking for a senior blockchain developer, a smart contract developer. So it's a harder industry to get into, definitely harder than traditional programming, web development and all that, because it's super new. However, I think in the long run, well, this is also proven by my own actions, right? That's why I'm learning to do this stuff, because I think in the long run, we will have a lot of smart contract developer. And as the world transitions towards smart contracts, you will find more and more, and obviously even entry options. But right now, the companies are probably like, yeah, we don't have time to teach. In blockchain, the time to market is super fast. Like I told you, it's super easy. You just need to deploy the contract on the network. There are no requirements for you to run a business on the blockchain, a decentralized application. So the idea is everybody is constantly shipping and creating functionalities. So it's kind of hard to teach juniors when you just want to ship. So it's still very early and there isn't a lot of junior opportunities. So you would have to do it the traditional way of learning it, trying to be as good as you can, trying to find the one opportunity that will get you inside the ecosystem, getting the one entry on your experience, and then I think from then on it gets better. But it's a hard industry to get into. I'm not saying not do it. I think definitely do it. Basically, I'm here because I thought of going either into machine learning or blockchain, and currently I'm choosing blockchain. So they were both super interesting and hard fields, but I chose this one. So I think go for it, but it won't be easy. I'm sorry. Yeah. How can someone overcome the loops inside a smart contract? I'm not sure what you mean by that. If you can rephrase the question a bit, I'll try to answer. I'll try to answer it as it is, but if you have more specific aspects, just let me know. The idea is that the smart contract, the way it works, like I mentioned before, you have to write the whole code in its final form, and then you deploy it to the network. To the Ethereum network, it's set in stone on the network, and from then onwards, you just call certain functions from that smart contract. You cannot change what is ran inside the contract. For example, in my example with deposit, withdraw, deposit to, if you call deposit, it's going to do what it says in deposit. There's no way for you to tamper with that and convince it to do some other loop or modify the loop inside of it. So from that perspective, it's safe. Yes, it's it's a bit of controversy that they ask for seniors when the technology is so new. But I think there was this well, it's like a joke, right? It's like a joke post on, I think, LinkedIn from the guy who created Elixir.js. And he found a job posting of a company requiring 5 years or 3 years of experience, and he had only created the framework for 1 year. So yeah, it's not that, but it's kind of that. People want to ship. Like, the idea is you want to create products and solutions to problems, because ultimately, if you do it like that, it's a business. Don't get me wrong. There are a lot of companies who provide just general availability to certain functionality, but they're not about making money. But if you want to work and be paid as a developer, you have to provide value. So you need to be good, especially in the current environment. So the idea is it might take time, but you will get there. Thank you, everybody, for participating. Have a good day. Bye.